Hello, today we're going to continue talking about finding the inverse from an equation. It's the same process we did in the last video. We're going to switch where x and y are in the equation, remembering that f of x or g of x or h of x is the same thing as y. Solve that new equation for y, and then write our answer in inverse notation. The only thing that looks a little different today, and you might have already noticed this, is that our starting problems have fractions in them. They either look like a big fraction like we see here in these top two, or they have other fractions in them like we see in these bottom two. Again, the same process remains, but we just have to, sometimes fractions can be scary. So we're going to tackle them a little differently just to deal with clearing out those fractions. But like I said, we start the same way. Remember that f of x is basically the same thing as y. If it's a g of x or h of x, same idea. So h of x is really the same as y. If I'm going to switch where x and y are in the equation, this y or h of x turns into x. The other side, this x becomes a y. So it's going to look like 4 plus 3y all over 4. From here, the goal is to solve the equation for y, aka let's get y by itself. So you may remember solving equations like this in the past. When you see something that looks like a big fraction, the way we undo that big fraction is we first multiply by the denominator, whatever the bottom number of the fraction is. So since I have a 4 down in the denominator, I'm going to multiply both sides by 4 to clear that fraction out. This side, 4 times x is just 4x. Divided by 4 and multiplied by 4 are opposites here, so I'm just left with the top of the fraction, 4 plus 3y. From here, solving for y is a lot friendlier now that that fraction's out of the way. I need to subtract 4 from both sides. 4x and minus 4 are not like terms, so we do not combine those. I'm going to get rid of that 4 because it's ugly. Much better. And then the last step to get y by itself is I need to divide both sides by 3. You're going to end up, if you start with a big fraction, chances are you're going to end up with a big fraction as your answer too. Leaving it as that big fraction is perfectly fine with me. At this point, we're almost done. The only thing we need to do is our inverse notation. With the last lesson, all of them start as f of x's, so we wrote it as f inverse x for our answer. Technically, this one is starting with h of x, so my final answer in inverse notation should be h inverse, which looks like h to the negative 1x, equals what we got on the other side of the equation, 4x minus 4, all divided by 3. The green there is my final answer, written in inverse notation. So the same process, we just have fractions in our starting problems. Nothing to be too scared of. For the next one, remember f of x is basically y. So we start by switching where x and y are in the equation. So the left-hand side becomes x. On the right-hand side, that x is going to turn into a y. It's another big fraction problem. To undo that big fraction, we multiply by the denominator, which is 3 on both sides. 3 times x is 3x. These 3's cancel here, and I'm left with the top of my fraction on the other side. Now I solve for y. Continue. So I subtract 3. And then last but not least, I divide both sides by 2. We're going to be left with this fraction here. You could break it up into 2 pieces, but it's going to still be fractions, so let's just leave it as a big fraction. I'm almost done. I just got that last finishing touch on inverse notation. I started with f of x, so f inverse x equals that big fraction I ended up with, 3x minus 3, all divided by 2. The last two also start with fractions in them. They look slightly different. When you don't have things written as a big fraction, you don't need to start by multiplying. You can undo any addition or subtraction first, then deal with your fraction. I will show you that here momentarily. We're going to start the same way though. Remember, g of x is basically the same as y. I'm going to go ahead and label that on the other one too. And then we switch where x and y are in the equation. So left-hand side becomes x. Right-hand side, this x turns into a y. We saw equations like this in the last one, except for instead of a fraction in front of y, it was a number like 2 or 3 or something that's not a fraction. So the way we solved those was we got rid of the addition or subtraction first. That's what we'll do here. So to undo this, technically plus 5, I'm going to subtract 5 from both sides. Normally, when we have a number in front of y, to undo that, we divide by that. But that means we would be dividing by a fraction. So our answer would look like a fraction on top of a fraction, which is really cumbersome. So the same thing as dividing by -9/5 is I can multiply by its reciprocal, which is the upside down version of that fraction. The reciprocal of -9/5 would be just flip that fraction around, and it still needs to be negative. I usually write that negative with the top number. So -9/5's reciprocal is -5/9. If I multiply by that on this side, I'm going to get 1y or y. Anything I multiply by one side on, I got to multiply the other side by. Since the other side has two terms, put it in parentheses because we'll have to distribute that -5/9. So like I said, -9/5 and its reciprocal cancel. I get just y here, so that's pretty slick. On the other side, I need to distribute that fraction. -5/9x doesn't really simplify. And then here, -5 times -5 is +25/9. So we multiply the whole number times the top number of the fraction. So y is by itself. We are basically done. The last step we need to take is write our answer in inverse notation. We started with g inverse x, so g of x, so I'm going to write g inverse x equals what I ended up with, those fractions there, -5/9x plus 25/9. That right there is your final answer. Let's try one more. So again, this one is not written as a big fraction, so once we get x and y switched, we're going to start by undoing this +3. But let's get x and y switched. Y turns into x turns into y. Undo the +3 by subtracting 3 from both sides. And then to undo that fraction in front, we multiply by the reciprocal. So since this is a negative fraction, a reciprocal will also be a negative fraction. Reciprocal of 3/2 is 2/3. So I'm going to be multiplying both sides by -2/3. Once again, since the left-hand side has two terms, we need to put it in parentheses because we'll distribute. Let's do that distributing. -2/3x. And I'm going to write the work for this off to the side. -2/3 times -3. I multiply the top of the fraction by the whole number. So -2 times -3 is +6. The bottom number of the fraction stays the same. And 6 divided by 3 is 2. You could do this in a calculator as well, no shame there. You'll end up with 2. So since it's positive, I'm going to write +2 here. The reciprocals cancel each other out. I get just y. Last but not least, I got to write my answer in inverse notation. So since I started with g of x, g inverse x equals all that stuff I ended up with, -2/3 x plus 2. So finding the inverse with fractions, not too big of a deal. If they start by looking like a big fraction, remember to multiply both sides by that bottom number of the fraction as your first step after you switch x and y. If you have a fraction in front of y, we undo the fraction in front of y by multiplying by the reciprocal, the upside down version of that fraction. If you start with fractions, you're going to get fractions in your answers usually. That is it for today. I hope you have a wonderful day.